All right, so I'm just going to talk about how to figure out the units of the rate constant lowercase k, and you can either memorize them, which you should do, um, just because it's fastest, but it's also helpful to know how to figure them out in case you have a brain fart in the middle of a test or something. So, um, for memorizing, just remember. So I'll just write it right here underneath each of the orders. So 0th order, it's going to be molarity over seconds. For first order, it's going to be 1 over seconds. Second order, it's 1 over molarity times seconds. For third order, it's going to be 1 over molarity squared times seconds. Now, real quick on why, so just kind of to explain it, if we remember from class, if we look at a graph and we measure the rate of a reaction, we measure it in, typically we'll say, at least for a 0th order reaction, the concentration of A over time, and in this case time is seconds. And for, the only thing that changes for a first, second, and third order reaction when compared to a 0th order reaction is, well, so this is always going to be the concentration of something. But for first order, it's ln, or the natural log of it. For second order, it's 1 over, right, and then so on and so forth. We typically deal with first and second order. We don't really do a whole lot with 0th order, and I don't even know if we do anything with third order, but I'll explain it anyways. But just remember that the concentration, or the concentration of A, is measured in molarity, which is moles per liter, and here it's seconds. And so when we talk about the rate, or capital R, the units of the rate are always molarity over seconds, and it's due to this graph. And so we'll go into why that is. So for a 0th order reaction, we know that the rate of the reaction is not dependent on the concentration of the reagents or the starting materials, and therefore we put the rate, or the rate, capital R, equal to the rate constant, so K. And we know that the rate is in units of molarity over seconds, and that's true for 0th, first, second, and third. For all orders of reactions, it's always molarity over seconds. And the way we figure out the rate constant, K, is by seeing what we have to multiply in order to basically get the same units on the right side as we have on the left side, so molarity over seconds. And if the rate, if R is equal to K, then we know that for a 0th order reaction, K, lowercase k, must be molarity over seconds as well, or else, they wouldn't cancel out. And so when we look at a first order reaction, we know that the rate of the reaction, capital R, is dependent on the concentration of one reagent multiplied by the rate constant. And if we look back to, like when I said with the graph, we have the concentration of A, it's measured in molarity. If we think about it, molarity, if we look at it in the form of basically, we'll say a fraction, molarity really is molarity over 1, because anything over 1 is itself, right? 2 over 1 equals 2. So, so if we look at, if we basically break down this rate law, or rate equation, into its units and solve that way, we get molarity over seconds for the capital R, and then the rate constant times molarity over 1. Or you could put this, in brackets. And basically the question we have to ask ourselves is, how are we going to get this side of the reaction, or the equation, to equal this side? And So if we look at these units right here, we already have molarity on top. We already have molarity, molarity. And so all we need is actually seconds on bottom. And so the only way to cancel that out is if K is equal to 1 over seconds. And so if we multiply, we'll just kind of take this over here, this side. If we do 1 over seconds times molarity over 1, we are going to get molarity over seconds, and that's equal to, that's the same units as the rate. And so therefore for a first order reaction, the units for the rate constant are going to be 1 over s. And if we move on to the second order reaction, just like we said before, the units of for the rate are molarity over seconds. And there are several ways you can see this. You can either have a second order, and we're talking about the order of the overall reaction. So it can be one reagent that's second order, or two reagents that are first order, because the overall reaction, say for this reaction, is second order, right? Because we have two first order reagents in the rate law. So regardless of what it is, if we take molarity over seconds equals to K times molarity over 1 squared, and on this side we get molarity over seconds, and it's going to be the same thing times K. We just have molarity over 1 times molarity over 1. Just do parentheses because it's a lot faster. That's going to give us the same thing. Molarity squared over 1 was K molarity squared over 1. And so when we look at this, we're trying to get this side again of the equation to equal the left side of the equation. Now when we look at the units, we see that we have 2 molarity on the top. We only have 1 molarity on the top. So we are going to have to somehow get molarity off of the top. And if you remember back to what basic algebra, the way we get a numerator off the top is by multiplying it by the same unit or molarity in the denominator. So I'm just going to take all of this, because it's all the same over here. We got molarity over seconds equals K molarity squared over 1. And so in order to get seconds on the bottom for this, and get single molarity on the top, K must be in units of 1 over molarity times seconds, because if we look over here, 1 over molarity times we'll say molarity squared over 1, this is going to cancel out one of these, and we are going to get molarity over 1. But because we also threw in seconds, we have 1 over molarity times seconds times molarity squared over 1. So this molarity is going to cancel out one of these, so put 1 right there, and then we are still going to get seconds on the bottom. So we get molarity over seconds. And then, I mean, obviously you have, what, times 1, but, you know, those just aren't included because it's 1. And that's how we get the units for a second order reaction. These are not the units right here. This is equal to R, the units of R. The units for the rate constant is right here. 1 over molarity times seconds, because that's what it takes to cancel out the molarity squared on the top. And now if we look at a third order reaction, just remember we have molarity times seconds equals K times either one reagent to the third order, or, you know, two reagents, one to second order, one to first order, or three reagents to first order, regardless of what it is. We have right here, if we look at these units, we have molarity over seconds equals K times molarity cubed over 1. Now, how are we going to cancel out? Remember, we only need one. We have one molar right here. We only need 1 molar right here. So we're going to have to put molar squared on the denominator somewhere, as well as seconds, because we need seconds on the bottom as well. So if K equals 1 over molar squared times seconds times molar cubed over 1, we're going to cancel out 2 of these and leave 1 molar, and then seconds is going to carry over on the denominator, and we are going to get molar over seconds, which is equal to the units of the rate, or capital R, and therefore the units of the rate constant for a third order reaction is actually this right here, or sorry, I'll write it right here, 1 over molar squared times seconds. And that's why, I mean, it's easier just to have these memorized. But in the case that you, I don't know, forget somehow in the middle of the test or whatever it may be, you can figure it out, and hopefully that made sense.